So part C of the experiment was burning magnesium. We measured our magnesium strip, and we measured the crucible and the crucible cover. And then we set up the Bunsen burner with the ring stand and the mesh, and we put that on there. And we put it in the flame for about 15 minutes. We didn't see much for that 15 minutes, and then we asked the teacher, and the teacher said we were just going to go ahead and put it in the flame. So we saw a big white flash on it, and we put that as quick as we could back into the crucible. We came up with an 11% error. That's most likely because some of the powder probably dropped when we put it in the flame, but it was pretty close. Okay, so part B of the experiment was producing a solid. He used copper sulfate and sodium hydroxide as our two chemicals. We measured the graduated cylinders, and then we measured the graduated cylinder with acid in them. And we measured the test tube and the beaker. Once we got our acids, or our chemicals, we added them both to the test tube, and within seconds the mixture wasn't liquid anymore. It became a solid, and it was the color of the copper sulfate. We came with a small % error. That's probably due to a couple drops that were still on the graduated cylinder, but for the most part the mass was pretty close to the same. All right. Okay, so part 1 of the law of conservation of mass was reacting steel wool with acid. We used a piece of steel wool and we put it in a flask. We measured the flask, we measured the steel wool, we measured 5 milliliters of acid. We added the acid to the steel wool, and then immediately put a balloon on so the gas wouldn't escape. And then we let that sit for about 10-ish minutes. The acid had turned yellow, and the balloon had popped up a little bit, and we measured it and the mass was the same. We calculated a small % error, about 1%. I think that was due to the few seconds the balloon was not on the flask, so that probably caused a little bit of dilemma there, but mass was almost the same. Right.